Okay, let's move on to our last presentation of this session. The next presentation is a study of Ethernet TSN profile based on JASPAR's automotive use cases. From JASPAR, Mr. Izumi and Professor Ito, let me invite you to the stage.
Nomura-san, thank you very much for your kind introduction. This is the last presentation before lunch. Maybe you are hungry, but wait another 30 minutes. I'm Tatsuya Izumi from Sumitomo Electric and JASPAR. It's my pleasure to be here with you today. So, before starting our presentation, let me introduce ourselves a little more. The speakers, I and Yoshihiro Ito, are representative of JASPAR, the technical consortium of Japanese OEM and suppliers. And special thanks to Tajima-san from Aubass. And co-authors are listed here, Goto-san and Yamasaki-san from Toyota, and Nomura-san from Honda, Kotani-san from DENSO, and Akizuki-san from NEC, and all members of JASPAR. So let's start the presentation. Today, we'd like to talk about Ethernet TSN profile based on JASPAR's automotive use cases. This is the agenda of today. Our presentation is divided into 3 parts. At first, we'll introduce the background and the objective of this presentation. And then, we'll focus on the study of Ethernet TSN profile, the main topic of this presentation. And finally, we'll talk about future works. So let's get started. These slides have been already explained by the other presentation from JASPAR yesterday. So we'll skip to explain. So in this tech day, there are 3 presentations from JASPAR. JASPAR's working is composed by 4 teams and 2 sub-teams. I'm the leader of the functional development team, and this is our presentation. So we show you the background of this presentation. This table shows the ABB and TSN profile. As you know, TSN has evolved from ABB for automotive use cases. In our understanding, the TSN is the toolbox, a collection of many standards specified by IEEE 802.1, such as time synchronization, quality of service, security, and so on. And the profile means the selection and the use of TSN tools. So we must standardize the profile for automotive. IEEE P802.1 DG is working on it. Next, we'll show you the JASPAR's contribution to date for the .1 DG. JASPAR has started the TSN profiling before 2018. To avoid the double standards for TSN profile, JASPAR has established the liaison with IEEE 802.1 working from 2019. We have contributed to the .1 DG from the point of view of the automotive use cases and the requirements. Contribution to the IEEE P802.1 DG is JASPAR's mission. So this table shows the DG profiles as is draft 1.4. The left column shows the TSN features, and the right side refers to the IEEE Standards 802.1. As you can see, DG profile composed by the base profile and extended profile. Base profile covers an essential set of TSN tools that are required in various use cases, such as infotainment and ADAS and security. In other words, the TSN base profile includes 3 TSN features, PSFP, FQTSS, and GPTP. Today, the time is limited, so we'd like to discuss the time synchronization according to JASPAR's use cases. Now, back to the agenda, and we have finished the introduction. So, let's move on to the study of Ethernet TSN profile. First, we'll introduce the JASPAR's automotive use case, and then we'll explain the differences in the existing profiles. And finally, we'll propose the JASPAR's profile based on analysis and solutions. So this diagram shows the example of the in-vehicle Ethernet network. NECUs are connected via Ethernet switch. The example of the NECU is telematics control unit, TCU, and in-vehicle infotainment, IVI, and the body control ECU. The example of Ethernet switch is central ECU and zonal ECU. We assume the communication software of the TCU is the automotive grade Linux AGL, and IBI uses AGL or Automotive adaptive platform, and the body ECU based on Automotive classic platform. And the example of the Ethernet switch communication software is assumed to be Avenue, .1AS, Automotive, etc. It depends on the software of the switch IC vendor, which profile has been adopted. We'd like to emphasize that JASPAR assumes the time synchronization under an environment where various communication software is used together, so now on the same time synchronization domain. So next, we'll explain the problem of the coexistence of the communication software. This table shows the communication softwares and the corresponding profiles. As you can see from this table, each software supports different profile. Let's take a look at this diagram. The origin of the profile of the time synchronization. Major profiles such as Avenue, Automotive, .1DG are based on the IEEE 1588 and 802.1AS. But these profiles are not the same as each other. So, if the profiles for automotive are not consolidated, ECUs based on the various profiles will be used together. So, we must consider the coexistence of ECUs which meet various profiles. We, JASPAR, would like to expect IEEE P802.1DG to bridge gaps between the standards that have already been issued and implemented. So we'll show you the difference in the existing profile for time synchronization based on the JASPAR's analysis. This table compares the characteristics of each profile, DG, AS, Avenue, and Automotive. As you can see from this table, there are some difference between the profile regarding time synchronization. In this presentation, we'll show you the two topics, two analyses. The first analysis concerns that the use of BMCA, a best master clock algorithm, and the announce message and the signaling message. And second analysis is about multiple time domains. Details of the difference and the resulting problems are shown in the following slides. So let's start the first analysis about BMCA, announce message, and signaling message. As you can see from this table, none of the .1DG avenue also assumes the use of BMCA now. According to JASPAR's understanding, the in-vehicle network is assumed to be a closed one for the present. So it is not necessary to elect the best grandmaster clock, which is decided uniquely. And the next item is about the announce message. .1DG adopt the announce message while avenue and outer don't. Even if the avenue and outer receive it, they ignore it. But the .1DG may make it optional in the future. Moreover, the adoption of the signaling message differs by profile. The difference in the adoption of the announce message, signaling message, hinders the interconnectivity. So we'll show you the details with specific example. This diagram is a use case that I described. So the TCU is the grandmaster of time synchronization, and the TCU notifies itself as grandmaster by announce message. And the behavior of the Ethernet switch depends on the profile to comply. So in this case, a switch cannot decide whether to propagate or drop announce message. Even if the switch propagates the announce message, the end ACU comply to what's the classic ignores it. So there are a problem on the interconnectivity. We'll show you the example of JASPAR solutions. First solution is that we adopt the static configuration by setting to TCU to master statically. Announce message and signaling message will be unnecessary. Second solution is that amendment to the 802.1 AS or IEEE 1588. For example, adding no announce mode. I know it's not easy, but if it works well, the interoperability can be guaranteed. We JASPAR has raised the issue to IEEE 802.1DG, and it is under discussion. So let's move on to the second analysis about multiple time domain. As you can see from these tables, so the .1DG and the auto supports multiple time domains. However, the specifications slightly differ from each other. Because OZA implemented it before the standardization of the 802.1s 2020. I will show you the example of the difference in terms of the parameter values. Version PDP indicates the version number of IEEE 1588. So the version PDP of .1DG is 2.1, but OZA is 2.0. And the range of domain number is differ from each other. Range of the DG is from 0 to 255. On the other hand, OZA is from 0 to 15. As I mentioned, since the two profiles differ from each other much, interoperability cannot be guaranteed. We'll show you the case study of the interoperability in the next slide. Our approach is that if we migrate the multiple domain specification of the author to that of the AS 2020, what happens? Version PDP is changed to 2.0 to 2.1 by migration. So the concern is that devices cannot distinguish the author profile and AS 2020 by version PDP. And back to the page, the author supports multiple domain network by internal parameter, the message compliance. So the range of domain number depends on whether message compliance is true or false. When the message compliance is true, multiple domain can be operated based on AS 2020, 0 to 255. When the message compliance is false, backward compatibility to existing of the specification should be considered. So the .1DG should decide to keep from 0 to 15 or change 0 to 255. So this approach can realize the interoperability between the .1DG and author, but limit the use of the extended format of author. So we explain the difference between the DG and author. What does author consider this issue? JASPAR signed MOU with author to promote collaborative activities. So according to JASPAR's understanding, the migration of the AS 2020 is under expert discussion in author. So the migration will not be reflected in the upcoming release, and it will be reflected in a release later than the release 23-11. So the JASPAR keeps an eye on the standardization of author profile while cooperating with author. So now the speakers change to Ito-san. Thank you so much.
From now, I will continue our presentation. So, Izumi-san, give me lots of chance to speak here. And so, let me introduce our consideration policy about profile for time synchronization. Now, JASPAR is studying automotive profiles from this point of view. It is how to realize the coexistence of current time synchronized networks with the ones based on IEEE P802.1DZ. Then, what should we consider coexistence? Do you think which is better for many devices implemented according to different profiles to work on the same network or separated network? In order to answer this question, we are evaluating the mutual interference between an implementation based on one profile and that on the other profiles. And then we will study JASPAR's profiles as an overall solution for existing various profiles. And so this is a part of JASPAR's profile under consideration. So at this point, I don't explain the details of this table, but the main crucial point the main crucial point in this table is coexistence with many various profiles. So we hope that the specification defined in IEEE 802.1DZ will bridge the gap. And let us introduce the JASPAR's approach for the coexistence. I will show how can we adapt TSN to Ethernet networks based on AutoZA specifications. For example, we want to add TSN functions to an Ethernet network with AutoZA-based time synchronization to realize ADAS functions. So here, we have three prerequisites and their corresponding issues. First, there already exists a network for time synchronization based on AutoZA. So it is very difficult to change the specification of the time synchronization network from AutoZA to the other to add new functions. Second, we want to realize Ethernet TSN while utilizing the existing network. However, as we have already shown, there are many many issues caused by the difference in profiles. Third, although we recognize the issues, there is no doubt about the usefulness of the Ethernet TSN in the ADAS functional area, etc. Therefore, we want to realize practical use as soon as possible. So we firmly expect P802.1DZ's activities to solve the gap between profiles by some means. Okay. And at this point, so I'd like to show our future works. As Izumi-san has already mentioned, IEEE P802.1DZ profile have two profiles. One is base profile and the other is extend profile. And although this presentation showed our study of profiles for time synchronization, JASPAR is discussing the other ones, including the base profile of IEEE 802.1DZ. And now, the details of the profile discussed by JASPAR are published on our web pages. So if you are interested in this document, please visit JASPAR's homepage and look at this document. And in addition, we are setting a TSN profile for Automotive SDN. And we will continue to study. The one example is presented by Nomura-san and Akizuki-san yesterday. And the Automotive SDN is one of the future use cases JASPAR considers. And we will continue to contribute to IEEE P802.1DZ by studying of TSN automotive profiles. And finally, I'd like to conclude our presentation by summarizing this presentation. And according to JASPAR's use case, There can be many devices based on various time synchronization profiles on the same clock domain. And since the profiles for time synchronization of IEEE P802.1DZ, Avenue, Autoza, and so on, these differ from each other. We have a problem with interoperability. So, JASPAR will continue to study the coexistence of devices with various profiles, while respecting the existing time synchronization profiles. And JASPAR is studying profiles for TSN functions other than time synchronization. And we will continue to contribute to IEEE P802.1DZ in the future. And finally, although AutoZA is the base for in-vehicle networks, but IEEE P802.1DZ's profile will be essential. Therefore, JASPAR, which has a liaison with both IEEE P802.1DZ and AutoZA, we want to serve as a bridge between them and contribute to standardization. Okay, thank you for your kind attention.
Mr. Izumi and Professor Ito, thank you very much for the interesting presentation. Now, let's open questions and comments from the audience.
Hi, Don Panel from NXP. Thank you very much for this hard work that you put into this. My background is I've been active in IEEE 802 for about 25 years now and AVB TSN since the beginning. So it's unfamiliar to a lot of people how in 802.1, what's the difference between a base standard and a profile? And that's very important to understand what 802.1 thinks about them. A base standard is a document that's intended for a lot of different use cases, like your domain number on slide 16. You mentioned that DG, or not DG, but AS 2020 has a large range of the domain number. But DG has every right to define a smaller range. That's what profiles do. The base standard is very broad and open, and in fact, for the industrial profile, they're choosing like 4 specific domain numbers at maximum, because that's what they need to use today, and they don't want to open it up more than that. So I don't see a problem with domain number and getting them aligned and having DG limit, because that's what profiles do. Profiles cannot add a new feature to a base standard. They cannot override something that's mandatory in the base standard and say now it's optional. But they can take anything that's optional in a base standard and make it mandatory. And so that these numbers here, what domain numbers you use, are optional. And DG can define these shall be the 1 or 2 or 3 or 16 numbers you're going to use. Okay, so I don't see a problem there. Now, even the announce, I know that's inconvenient right now, and we're having large discussions about that, and industrial guys don't want to announce. The aviation, the DP profile that's being done, they don't want to announce, but it's a hard requirement of 1588. So I don't see a coexistence problem, as you brought up on a later slide, with announce, when you're telling me AutoSAR ignores it. So if you did have a device that talks to another device that's AutoSAR, because that sounds like that's what you're trying to get coexistence with. If I sent you the announce and you're AutoSAR, you're supposedly supposed to ignore it. I get coexistence. Yes, I sent a useless message to you, but I don't send it that often. You can change the announce interval to be really long. I mean, I'm hoping that's acceptable. We got to find compromises to deal with things that have been done already, right? And how do we move forward? And so I think the biggest thing that I was hearing, you want DG to solve the gap. And it's really, how are we going to collectively solve the gap? Because DG doesn't know what's going to be acceptable to JASPAR, right? And so it's a collective working together to solve this gap and merge it together. And I've already suggested a few ideas, and I really appreciate that you're contributing. And maybe this is a language difference, but I think you need to step it up to not just contribute, but to be active for maybe a year in the committees and the meetings to argue your points, to help get the consensus and people understanding what your problem is, and for you to come back and say, that can work or that can't work, right? Because otherwise it's going to take forever. So thank you very much. I hope we can merge like you're talking about, but 802 is all volunteer work. So, expecting volunteers to do what you want, they have no interest. So please help people understand, and you volunteer some time to it. Thank you.
Thank you very much.
Any other question and comment? I see none. Oh, okay, that's all presentation we have for this session. I'd like to thank both the speakers and the audience for providing such an interesting presentation and discussion. Everyone, please give a big hand for speakers and once again. The next session will be started at 2 o'clock. Enjoy lunch.